Perfectly inelastic collisions. Perfectly inelastic collisions can be analyzed in terms of momentum. Perfectly inelastic collisions occur when in collisions in which two objects stick together after colliding. The equation for perfectly inelastic collisions is m1 v1i plus m2 v2i is equal to m1 plus m2 times the velocity final. So in other words, the mass of the object 1 times its initial velocity plus the mass of object 2 times its initial velocity is equal to the summation of the masses times their final velocity. All right, so let's do a perfectly inelastic collision example. An 1,850 kilogram car stopped at a light is struck from the rear by a 975 kilogram car. The two cars become entangled as a result of the collision. If the compact car was moving at a velocity of 22.0 meters per second to the north before the collision, what is the velocity of the entangled mass after the collision? All right, so let's do an example. So we have the mass of the first vehicle being 1850 kilograms. It's going 0 meters per second. The second one is 975 kilograms, going 22.0 meters per second to the north. We're looking for the velocity final. So remember that in elastic collisions, the mass of the first object times its initial velocity plus the mass of the second object times its initial velocity is equal to the masses added together times the final velocity. So we're looking for final velocity, so we're going to put it in that term. So we're going to divide the summation of the masses across. So we get m1 times vi initial plus m2 times v2 initial divided by m1 plus m2. But remember that since the first vehicle was at 0 velocity, which means it was at rest, that this also goes to 0 because anything multiplied by 0 is 0. So we don't have to worry about that part of the equation. So we're really going to do the mass of the second one times its velocity divided by the mass of the two objects together. So we're going to take 975 kilograms times 22.0 meters per second north. And we're going to divide that by the summation of the masses, which is 1,850 kilograms plus 975 kilograms. So my velocity final becomes 7.59 meters per second north. So to the north. All right, let's talk about if this makes sense. Okay, so this object is about double the size of this object. I have 22 meters per second here. When I add them together, that means that my mass is triple what it was here. So my velocity final should be about a third of what it was initially. So I had 22.0 meters per second to the north. I have 7.59 meters per second to the north. And we know that 21, a third of that, or we're going to divide that by 3, is around 7. So yes, this makes total sense. Kinetic energy and inelastic collisions. Kinetic energy is conserved in inelastic collisions. Now let's do an example of kinetic energy in perfectly inelastic collisions. Two clay balls collide head-on in a perfectly inelastic collision. The first ball has a mass of 0.500 kilograms and an initial velocity of 4.00 meters per second to the right. The second ball has a mass of 0.250 kilograms and an initial velocity of 3.00 meters per second to the left. What is the decrease in kinetic energy during the collision? All right, so for this problem, we know the mass of the first clay ball is 0.500 kilograms, moving at 4.00 meters per second to the right. The second clay ball is 0.250 kilograms, moving at 3.00 meters per second to the left. We're going to need to find the velocity final and the change in kinetic energy. So to get the kinetic energy initial, remember that the change in kinetic energy is kinetic energy final minus kinetic energy initial. The kinetic energy initial is equal to 1/2 m1, so the mass of the first object, times the velocity 1 initial squared plus 1/2 m2 velocity initial 2 squared. So plugging in, we get 1/2 times 0.500 kilograms times 4.00 meters per second squared plus 1/2 0.250 kilograms times 3.00 meters per second, and that's squared. Okay. And velocity, so we're going to calculate this to be so I get 1, all right, sorry, no, 0.5 times 0.5 times 4 squared plus so we get 5.13 joules. So that is my KE initial. I need to get my V final. So my V final is equal to my mass of the first of object, V initial, V1 initial, plus my mass of the object 2, V2 initial, divided by the masses added together. Okay, so that is 0.500 kilograms times 4.00 meters per second plus 0.250 kilograms times a minus 3.00 meters per second divided by the masses added together, so 0.500 kilograms plus 0.250 kilograms, and that happens to equal 1.67 meters per second to the right. Okay, so then we gotta find the kinetic energy final. So kinetic energy final is equal to 1/2 the mass, which is m1 plus m2 times velocity final squared. So we get 1/2 0.500 kilograms plus 0.250 kilograms times the 1.67 meters per second right, and that's squared. So my final becomes, so KE final is equal to 1.05 joules. So we're going to take, to find our delta K, here. Okay, so to find our delta K here, we're going to do this. Delta KE is equal to kinetic energy final minus kinetic energy initial. So that is 1.05 joules minus 5.13 joules. So my delta KE is equal to negative 4.08 joules. Okay, negative 4.08 joules.